when I subtract all of this, I should get 27 degrees. So this, I can fill in 27 degrees. Great. Now, I want to use, oh yeah, no problem. So Joseph, if you just arrived, I'll make a little announcement at the end about some work, okay? So now I want to use my side that I'm given. So I'm going to use the 13 with this now 27 that I know. Maybe I should fill it in. This is 27, right? And I'm going to take this and I can set it equal to little b over sine of 105. Or I could set it equal to little a over sine of 48. So I'm going to make my equations here solve. So let's see. So I would have, and I'm using, keep in mind, I'm using this up here, right? So I'm going to say little c, which is 13. So I'm using c over sine c equals b over sine b. I'm just solving b first. It doesn't really matter what order you go in, though you could pick a. But so 13 over sine of 27 degrees is going to equal little b, I don't know what that is, over sine 105 degrees, right? So you can cross multiply and solve if you want here, or just multiply both sides, right, by sine of 105 degrees. And you definitely need a calculator here. So enter, okay, this was a really bad, like, times there. It should be just times. So in your calculator, you can put sine of 105 times 13, all divided by 27, the sine of 27, and just make sure that's entered correctly. And so then we get that these cancel, right? And we get little b is approximately, or well, I guess maybe I'll write it one more time. So 13 sine of 105 degrees over sine of 27 degrees. There's no shortcuts there, right? You have to enter all of that. And this is approximately equal. I rounded to one decimal place like they asked, right? I got to remember that. And I get 27.7 degree. Oh, not degrees. It's a side. So now I can fill in little b is about 27.7. Then I do the same thing for a. You could use your little b, but I'd rather not. So I'm going to just use the 13 over sine 27 again. But this time I'm going to set it equal, like looking up here. This time I'm going to replace this with little a and sine a. So this should equal a over sine of what was a, 48 degrees. So again, I multiply both sides by sine of 48 degrees times sine 48 degrees, right? Times 13. And I get, let's see, little a, it's going to be 13 sine of 48 divided by sine of 27. And you should get about 21.3. And just make sure you're in degree mode. That's like the only reason in this case that you should really get anything wrong, right? Just make sure you're in the right mode. Okay, so that was an example of angle, side angle. And now notice how we found everything. We found all three angles and all three sides, right? So that's kind of what we were looking to do. That's what we're looking to do in these types of problems. We don't need to get like the whole dropping down in the middle and making a right triangle. We are never going to do that. That was just to show us. And just to confirm, if it's not a right triangle, we can't use Pythagorean theorem. Yeah, correct. So if it is not a right triangle, Pythagorean theorem does not work. So note, if not a right triangle, then Pythagorean theorem does not apply. Yeah, thank you for confirming that, because that's really important. Some students like will do that, and it's a very common mistake, but you have to be careful, because if you don't have a triangle, that's not how that goes, right? Okay. So now, well, this was angle, side, angle, and this would also work if we were given side, angle, angle. So if they gave like these two the same, okay, so let me just try to maybe like highlight in some other weird color. If they gave us, oh wow, that was just not good. All right, give me a sec. Oh. Why is that working? Here we go. Okay, so if they gave us like 48 and 105, and then they gave us A or something, that would be a case of side, angle, angle. Okay, so side, angle, angle. We also could have solved the same way that we just solved. Basically, if you have two angles and a side, this is what you're doing. Now, if we have side, side angle, this is a little bit weird, right? This is what we're calling an ambiguous case, okay? So now they're describing the triangle, and you don't need to draw it by any means, but I always try to draw it because it helps me make sense of anything. So solve the triangle where, and you could literally, like, it doesn't even matter. This does not need to be to scale. So I'm just going to draw ABC. My B is 28 degrees. My little b has to be across from my big B. So this is 10. Little a is 18. Little c we don't know. And the other angles we don't know. So round the measures of the unknown angles and side to 1 decimal place. Okay, that's just, thank you. So what we want to do is we just want to figure out what can we use here. This might be, I mean, we can use law of sines, but this is just a little bit, maybe it's a little bit more work, maybe not. So first up, I will take my, like, what I know. So I don't know capital A, but I know little a, and then I know both B's, right? So I'm going to take this and I'm going to think of little b over sine capital B has to equal little a over sine capital A. So I'm going to fill that in. I'm going to say 10 over sine of 28 degrees has to equal 18 over sine of capital A. Now, here's where you could cross multiply to solve, or so again, you could cross multiply this to solve. And that's what I will do and write it out for you. But what that does is it's 18 sine of 28 degrees is equal to, well, it doesn't matter what order you do it in. Maybe you would do 10 sine A first equals 18 sine 28, right? In which case, just divide both sides by 10. So some people can just automatically get to this step, and that's perfectly fine. So then sine A is this whole thing, and I'm just gonna approximate that decimal. So sine A is about, actually, oh no, I forgot, we have to do inverse. Okay. So I'm gonna write this 18 sine 28 degrees over 10. Now, in order to figure out what this, like what angle this is, we will have to take the inverse sine of this, right? However, we also need to keep in mind, we do sort of need to keep in mind like where this might be on our unit circle, like sine of 28, where is that? And is it positive or negative? Because if this was like 100 something, it just might, I don't know, it might be doing something funky. But I mean, for now, I think we don't have to worry about this, but let's see. I don't think we'll ever have to necessarily worry about it, but sometimes the inverse function can be a little bit strange. So for this, we're going to say A is then inverse sine of 18 sine 28 degrees over 10. So let's see. And if you put this in a calculator and get an error, let me know. But hopefully Hopefully that's not the case. Because I did compute this earlier and I was successful at least a little, right? So, so what I get here is I get 57.7 degrees. Okay. But what I will show you is, so what we're looking at here, if we look at back to our handy dandy 0, 90, 180, oh geez, and then maybe this is negative 90 instead of 270. So if we look, typically sine, whenever we looked at sine and the inverse, right? Because remember, the inverse is restricted. I think cosine was 0 to pi, or 0 to 180, and sine was negative 90 to 90. Oh, and I lost you on it. Okay, someone say something. Am I still with you on the iPad?
Yeah, audio wise, yes.
Oh, great. Okay, so you can't see me, but I'm with you. I can talk. My computer hopefully will connect. So from negative 90 to 90, this is, or negative pi over 2 to pi over 2, this is what inverse sine is like, or that's where it lies. However, our triangle, or our triangle might look like this blue one that I'm going to draw. Where this angle is A, so it could be 57.7, but it could also, just because we don't really know, because we're not starting with a right triangle, it could also be, oh wow, my computer is all crazy. It could also be on the other side where our A is actually here. Okay. And the way that we would find this, so what's happening is the blue A is our reference angle, and it would be the same as this. So to find the green, we would do 180. So to find the green A, we would do 180 minus, well, okay, minus this entire thing. Okay. We don't know. So this is what I'm talking about, where if you have side angle, it's pretty much the worst case. It's this ambiguous case where there's like multiple correct answers, okay, based on whatever they give you. So there's multiple correct answers. And the first answer is the 57.7, the one that we just got. And on a test or a quiz, I'll have to check if I may accept either. Oh, I have to pull the chat back up. So if there's been any chat.
Recording in progress.
Okay, great. Alex, okay, so Jakob says Alex wants to 4 decimal places. That's kind of wild, but that's fine. You know how to do that, but thank you for letting us know. For whatever reason, we're sticking with 1 decimal place, probably because it's more sane and just a little easier. But what you would do here is you would subtract 180 minus this whole thing, and that gives us about 122.3 degrees. So now we've got this triangle 1 and triangle 2. That's why they have this triangle 2 will be our green, triangle 1 will be our blue. Now, what I'll write in black is what stays the same. What we're given stays the same. Little b, little b. What else were we given? Capital B was 28 degrees, right? And then little a they gave us was 18. Okay, so these stay the same and everything else will be different. So in the first triangle, if the triangle is to the right, like if it is this, there are just basically 2 answers here, right? If it's this one, then angle A is 57.7, and then we go from there and we can solve the rest of this, right? If it is the green triangle, it's 122.3 degrees. Oh, I should be writing degrees. Now keep in mind from here, right? From here, what I'm going to do is to find C, I'm just going to take 180 minus 28 minus 57.7, because they all should add up to 180. And from so blue C is going to equal this, whereas green C is going to equal 180 minus 28 minus 122.3. So we should get, it's like, well, 94.3 for blue degrees and 29.7. Yeah, so, okay, so what Jakob is saying is that in Alex, so note, maybe I'll write this. Alex wants 4 decimal places. So do not round on the homework. Okay, so that otherwise every answer is wrong. Now it's going to be a little trickier with multiple decimal places here and like subtracting and multiplying about whatever you're doing, right? Taking inverse, sine, or but just make sure you're using your calculator and taking it one step at a time. You should be okay. So now we've got almost everything. We just need little c. Now to get little c, I'm going to use so to get little c, I now know my big C, like I know what this is. So to get little c, I'm going to use this ratio, and I'm going to use again the A, or no, maybe I'll use B because that's what they gave me originally. But I just use different capital C's, right? So for the blue, let's start with the triangle 1. I'm going to say, and maybe I'll do it above here. I'm using this except C and C here, right? So I'm going to say 10 over sine of 28 degrees is going to equal little c, which I don't know, over sine of 94.3 degrees. Now, in Alex, use all 4 decimal places here. Otherwise, you're going to get, like Jakob said, everything's going to be wrong. So use all those decimal places. So really, I just multiply both sides by sine. Oh my God, 94. Yeah, 94.3. So this is times sine 94.3, right? And my little c is going to be, what did I get? I got about 21.2. So that's what I'm getting here, about 21.2. And again, we're only rounding to 1 decimal. So keep in mind in the homework, round to those 4 decimal places. And then for this next part, we're going to still do 10 over sine of 28 degrees. But then we say this is going to equal little c again over sine of now our other c, our 29.7 degrees, right? And so maybe I should rewrite this somewhere so it's not in our way. So then I'm going to multiply both sides by sine 29.7 degrees. Maybe I'll write it here, sine 29.7 degrees, right? And when you enter this in your calculator, you should get little c is about 10.6. And then you can look at this and make sure, okay, do all of my angles for each triangle, like you can then look at all of your answers, right? And say, okay, do all of my angles add up to 180? Yes. And all of my sides, does it make sense? Like they gave us 18 and 10, but if I got 50 for another side, that seems a little too high, right? Or if I got 1, okay, 1 isn't going to go with another side that's big, that's that much bigger. And David's asking, in essence, these problems you just have to do twice because there's several answers. Exactly. So again, on the test, I'm not positive if we make you do, I'll have to check if we make you do both, right? And if we do, then all you have to do to get that other triangle is look for that other angle and subtract your original answer from 180. Like that's all you have to do, and then replace, you know, in your little ratios here, replace that angle. So it shouldn't be too bad. Is this only when, this is not, so yes, for now, Colby, yes, this is only when you're going to use sine or arc sine, right? But if you want to know, like, when do I do this in general, you always do this, or this will always happen when you have side angle. This right here. It doesn't really have to do with like sine or cosine. It has to do with, they give you side angle, because we might be able to use cosine in a different way later, but they give you side angle, and that's when you know, okay, this is the ambiguous case, and I'm going to have to figure out what the heck's going on here, right? So hopefully that answered all the questions. Now this next one is going to be similar, but it's a case where the answer doesn't quite make sense for one of them. Like for both of these, if I look at all these, it made sense, it worked out, the angles worked. But in the next one, we're going to look and it may not. So there is a chance that for a problem like this, only one of the answers is correct because the other is like out of a range, or like out of the range of the function or something, right? So when we see that, and again, on a test, I don't think we'll give you something this complicated, but be warned that in your homework, this might happen. So if you're like, wait, there should be two answers, but there's only one, it's because of this, like, well, something like this. So let's take a look. So if we solve the triangle where capital A is this, little a and little b. Okay, so again, I'm going to just, maybe I'll draw it over here this time. I'm going to draw a triangle with capital A, B, C, and little a. Oh, whoops, I did not do that right. Remember, the little a goes across from capital A and etc. So we've got, this is 28 degrees, little a is 12, little b is 38. Wow, that's big. So again, if you get something for little c that's like 5 or 10, it's probably not going to be big enough, but we'll see, right? Okay, so we're given all of these, and again, I can look at what we have, and I see this ratio right away we're given, so I can try to solve for little b first, and then subtract, or big B, sorry, and then subtract and get, like, we always do the angles first in this case, and then the sides after, right? So let's take a look at what this is. So I'm going to have 12, because this is, I'm doing A over sine of 28, has to equal 38 over sine of capital B. Okay, so if I cross multiply, or if you want a little shortcut here with, like, you can cross multiply this, right? And then divide by 12, or you can just cross multiply, like do this first part, but then know that you're going to divide, like, cause you get 12 times sine B, right? But if you just want sine B by itself, you can divide by what's left. Now, if you don't like this, write it all out. I am being a bit lazy, and I know normally I will write all the steps. So if this is confusing, someone just stop me and I can fix it. But I'm going to get sine capital B equals 38 sine 28 degrees divided by 12. I just kind of skipped one little step there. Okay. Now, let's see what this is. So if you tried right away to just say B equals if you tried this, right, inverse sine 38 sine 28 degrees over 12, if you did this, your calculator would be like error, no, like wrong, undefined, I don't know. And reason is this decimal, which I didn't get before, maybe I should have, is about 1.49, et cetera, et cetera. Okay, I lost you on my computer, but hopefully you can still hear me. So if you can't still hear me, well, or I guess if you can, you should say something. Can someone say something?
Yeah, it's fine.
Okay, okay. All right. All right, this is so weird because like you're on, it's just weird to me. Okay, because I lose Zoom on my laptop. It's got to be a combo of my internet, but also my laptop is from 2013, so it's just old. Okay, so yeah, so it's almost 10 years. It's going strong. It needs to last me till December, right? Okay, so we have, if you enter this in a calculator, this will give you an error, right? And we will be sad and it will not be fun. But the reason is this, you are trying to enter in your calculator inverse sine of 1.49. What is the range of sine? Think about the sine curve just for a second, right? Sine, like la, 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 regular sine. The range is -1 to 1. So if I'm taking the inverse of this and I'm trying to figure out what angle gets me 1.49, this is not going to happen because this is out of the range of sine. So this like sine of B can never equal something like this number, right? And because of this, oh, you're back, so I'll pull up the chat. Okay. Yeah, 1.5. It's not a triangle. So because of this, your answer actually, you don't even get one answer. You just get the answer is not a triangle. So they are tricking you. So your homework probably will give you something like this, but on a test, we never will. Because then, well, okay, I won't say never, but it'll maybe be a part of a question, but it wouldn't be a question by itself because it's not a triangle. And what that means is that if you were to actually draw this to scale, so I drew just a random triangle, random, not to scale, right? But if you were to draw something to scale, right? So say, 28 degrees is small. I don't know, say that's it. Then I know this was 28 degrees. Then 38, like that's like maybe that long. I don't know. Then 12 was this side here, right? Maybe it's like less than half of 38. And so to get what's happening is to get a line, something to connect, that is this angle, it's not going to work out. Like in order to get 28 degrees here and have this side be 38 and this side be 12, there's going to be this gap here. And it's not, okay, maybe I should erase my lovely sine curve here. But there's going to be this gap. And it's where it ends, and this does not meet. So they would need to lower this line, could connect, that would change this angle, or they would need to extend this side, but that would change the 12 that they gave us. So, and David asked a question, I'm sorry, a minute ago. Sorry, why is it out of range again? Is it in the wrong quadrant? So no, this is not in the wrong quadrant. 1.49. So we have that, we are given here that sine of B equals this number. So sine of B equals 1.49. Sine of any angle can only equal a number from -1 to 1. It can never be more than 1. And so to be 1.5, 1.49, whatever, does that, okay, good. So I maybe explained it better that time. So thank you for asking again. And so the answer here that you get is just not a triangle, and you would need to show some work. If you did see this, or if you see this, well, in Alex, hopefully it's probably multiple choice or something, or it says if there's no answer, put like N, none, or, something like that. So just be aware of that. Okay. Now part C, so another one, and I think this should be maybe a good one because, so far it looks like it. So what do they give us? They give us one angle and two sides. The side angle, right? So remember, if we go all the way back, so bear with me, we saw the awkward side angle here, the ambiguous case. This one is probably going to be, so we saw, oh, did we not see everything yet? All right, let's see. Maybe I should just not scroll around and get all crazy. Well, let's draw this out and see what we get here. Okay, so 68 degrees, I'll make this my C, right? I'll make this B and this A, which means little c is over here, that's 15. Little b is over here, that's 13. And little a is there. Okay, so let's fill in what we know also, right? 68 degrees. So they actually give us, okay, this is another side angle, right? So I'm not entirely sure. Maybe this is just a nice one that they're showing us. So let's see.
Be a right triangle or maybe an oblique.
Yeah, something like that. So let's just see. I mean, it's just another example, really, but I thought it was more than that. So let's see. Little b is 13, little c is 15. Yeah, so we have 13 and 15. That is kind of nice because that means, well, I know it should work out because if the sides are that close together in length in 68 degrees, we should be able to form a triangle with this. Okay, so I first see that I can use the ratio of little c over sine c equal to whichever. I'll start with B, right? We start with getting all of our angles. So I'm going to do 15 over sine of 68 degrees has to equal 13 over sine of capital B. And then I do my little cross multiplying. And remember, it'll just be this 13 times sine 68 divided by 15. So I'm just going to write that. So sine of B is going to equal 13 sine of 68 degrees over 15. Now, maybe after what we just saw, maybe I want to check, is this between -1 and 1? And I get like 0.804 or something. So, right, so this is, so now we're good to go. I'm feeling good about it, right? So this is the example I was thinking of where there is only one answer when you have side angle. And the other answer, it doesn't work. So let's take a look. So we think of, we could either have it going this way or going this way, our right triangles. So we could either have an angle here or the angle could be this whole angle here. So when we solve for sine, we're going to get B is inverse sine of this whole 13 sine 68 degrees over 15. So if I do that, I get about 53.5 degrees, right? So that works. It could be 53.5 degrees. But remember, with a problem like this, all I have to do to figure out, is there another angle, is say B could also be 180 minus 53.5 degrees. Because it could also be 180 minus this guy. And that ends up being, what is that? 126.5. And I could still say, yeah, sure, that could be an angle, right? But what you need to check here. So let's say this was true. Let's say there were two triangles, just like before. Let's say triangle 1, triangle 2. And you don't need to write all of this, but let's just say there were two triangles, right? Triangle 1, my angle B was 53.5 degrees. I'm not getting an error. I'm feeling good. Triangle 2, it's 126.5 degrees. Okay, but keep in mind, this is 68 degrees and then whatever, 13 and 15, right? Now, when I go to find angle A, so angle A is going to be 180 minus 68 that they gave us, minus what we got for, so it's minus C minus what we got for B, right? That's how we get A. So, 53.5, oops. So here I get, okay, 58.5 degrees. That's perfectly fine, 58.5. We're killing it so far, right? But then I go here, I get A is 180 minus 68 degrees, minus 126.5 degrees. Okay, this, I don't know about you, but I get negative 14.5 degrees. Eek, that kind of seems like that shouldn't be true, right? That seems like we shouldn't be able to do this. So we get a negative number. So what happens is there is no triangle from this, well, we'll call it the obtuse angle because it was 126, right? So angle B. So then what happens is this whole triangle goes away and we have less work, or yeah, we have less work to do, right? You should still check it, but now all we have to do is find little a. And so to do that, I'm gonna again use my little c over sine big C and a over sine big A. So I'm gonna say 15 over sine of 68 degrees is gonna equal little a over sine, what do we get for big A, of 58.5 degrees. And then all you have to do is multiply both sides by sine 58.5 degrees, sine 58.5 degrees. And then I'll get that little a is approximately equal to, so you would enter 15 sine of 58.5 degrees divided by sine of 68 degrees. And I get about 13.8. So, and that makes sense because my other sides are 13 and 15. So yeah, seems like that could be in a ballpark. It doesn't seem unreasonable. Okay, so now we're just going to summarize what we saw, right? Or what we can see here. So side-side angle. In every possible triangle, the possibilities that we can get for side-side angle. So the first one, no triangle possible. This was example B above, right? Just scroll up. It was right. And that's where what's technically happening is, what's happening is, as you can see from what we got, that we actually get an error when we're calculating the inverse trig function. But in general, what's happening is little a is less than, if we were to draw a right triangle inside this potential triangle, little a would be less than h here, just in this picture, right? That's what's happening. But again, you don't need to note this. These are just all the possible outcomes. You don't need to memorize this or anything. You just need, if you get an error, what's going on and why. And it just means there's no possible triangle with these given angles and sides, right? We could have one right triangle. This is something we've seen before, saw before. I don't know, not today, right? Then one oblique triangle. So this we saw, this was in, I'll write example C above. It's only one triangle, right? Only one of them worked. We crossed out that second one. And that's because we got a negative angle for the third angle, and that doesn't make any sense. And then the last one was example A, two possible triangles. That was kind of a lot of work, right? But it was two possible triangles here. Okay. And then below, they're just telling you that, okay, so A is less than H, A equals H, like that's when you actually have a right triangle. A is greater, little a is greater than little b. And this is if you draw the triangle this way. I was also drawing it in different ways, so these letters could be different. And then A is between H and B. So that's, again, if you're looking at these particular pictures, right? So now suppose we're given the following triangle. What happens when we try to do law of sines? Okay, so what are we given? We are given a side, an angle, and a side. So this one is what we call SAS here, well, side angle side, right? And if I tried to do law of sines, I could do, okay, let's see. Maybe I could try little a over sine of 38 is equal to 22 over sine of capital C. So if I did that, well, I have two variables, so that's not going to work. But what we can see here, I can keep doing this for all of them. I'm not going to write them all out. But what we can see is that if we just look at what's across, I have one angle, but no side there. Then if I look at B, I have no angle, but one side here. And if I look at C, I only have one of everything. So I actually can't solve anything here because with law of sines, right? So what's going on is we don't have a full known ratio, like a side over an angle, right? So we need either more info, cosine maybe, right? All right, so maybe cosine is going to get us a little something here. And keep in mind, that's whenever you're going to have side, angle, side. So let's take a look. Okay. So here's the fabulous law of cosines. And again, last class I mentioned like, oh, we're going to do law of sines and cosines eventually. Yeah, here it is. It happened today. I was right. I was right for once, right? So we have this law of cosines. And it's this equation where if you have a triangle like this, where the lowercase letters are across from their capital letters and the capital letters are the angles, lowercase, maybe all of this, cap letters are the angles. This is just a reminder. Lowercase are the sides. They have to be, notice they have to be across from each other, right? B is across from B, A is across from A, C is across from C. It has to be this way, okay? Then the formula is this, C squared minus or equals A squared plus B squared minus 2AB cosine of C. Now you could replace this, you could move A, B, and C however you want. However, what has to be the same, this C and this C, these letters have to match. I mean, one of them is capital, one of them is lowercase, right? One's an angle and one's a side, but they could be they could be any like A, B, or C. So, but can replace with A, B, or C. So if, just one quick example, if we wanted B instead, we would get B squared. So example, we'd get B squared equals A squared plus C squared minus 2AC. So notice how these two letters, A and B, match the letters here, A and B. Okay, so I'm doing that on purpose. And then cosine of, it has to match this first letter, so capital B. And same thing, we can replace that with A. Okay, so it doesn't really matter which side it is, but the equation has to follow this pattern, right? Or and what this is, what is the law of cosines? Well, this is actually a generalization of the Pythagorean theorem. Because Pythagorean theorem is like a special case. It has to be a right triangle. So this is actually kind of like a generalization of that theorem. Yeah. Okay. And now let's put it to work. Let's see if we can solve with this. So again, it's going to be side, angle, side. So let's see. We start with the known angle. The smaller is an acute one. And then we can solve for everything else, right? So let's see Let's see what they say. Wait, solve what? There's no, oh, it's previous page. Previous, I'm gonna redraw it. Page. So they're talking this triangle right here. Okay, that confused me for a minute, but we're back in action. So let me just redraw it. Here, let me try to find it on here and redraw it so we have it. So again, nothing I ever draw will be to scale for these because that would be difficult. And so don't assume that any of these are to scale. Okay. So they gave us 19 is little b, 22 is little c, and 38 degrees is angle A. Okay, we're back in action. So it says start with the known angle. So the known angle is 38. Find the smaller of the two remaining angles. So our known angle is 38. I want to either find, B or C. Now, how do I know which one is smaller? It's probably across from the, I could just find a side first. It's across from usually the bigger side, but I actually am realizing I don't know exactly why they give us like this little tip here. Because we're not going to necessarily follow it. So that is just a recommendation maybe, but let's see, maybe we are following it and I don't know. Let's see. So what I would do first is try to find A because I know angle A. So let's try to find little a. So that would be like A squared equals B squared plus C squared minus 2BC cosine of big A. Right? So let's do this. So I'm going to get A squared and I know B and I know C and I know A. So I think this is the way to go. So we've got 19 squared plus 22 squared minus 2 times 19 times 22 times cosine of 38 degrees. And you can just put all of that in your calculator. Don't worry about it. Now, however, when you're rounding this, I would not round this yet. What I would do, and I know I'm writing a lot here, but what I would do is I would take the square root of both sides. Luckily, we can only have positive numbers here, so we don't have to know plus or minus, right? And I would enter this entire square root into your calculator, because if you round, okay, you can just do square root of your answer, but if you round, you're not going to get the right decimal here, especially in homework. If you have to round to 4 decimal places, you want to make sure, you're entering that whole thing. So if we do that, then I get A should be, I'm only rounding to 1 decimal. So that's nice. But A should be about 13.6. And I didn't fill out initially, right? I should fill out in my triangle here. Little b was 19, 2, and we just found 13.6. Okay, so I think now the advice is once all the sides are known, now this is where it's saying start with the known angle and find the smaller of the two. Okay, it doesn't really matter in this case, because what we do now, you might think, what the heck do you do now? Well, you could use law of cosines again and try to find angle, but that's a lot of work and you'd have to solve for the cosine and then take the inverse. So I'm going to say revert back now. So now revert back to law of sines to finish solving. Because now we can do law of sines. So watch, we can do, what do we got here? I want to find, maybe I'll start with B maybe, right? And it doesn't really matter here, but I'll start with B and I'll say, okay, 19 over, I'll say 19 over sine of capital B has to equal. And then what did we just find? We found A, so it has to equal little a, which we just found, over sine of 38. So we found 13.6. And you would want to use all 4 decimal places if you had to, like for your homework, and over sine of 38 degrees. So for this, you could cross multiply or do the little trick, right, where I multiply these and I'll divide by the 13.6. So I get sine of B is 19 sine of 38 degrees divided by 13.6. And now what we do, so in this case, we're going to say, well, we take the inverse sine, right? So B, and maybe you make sure, do not round this right here. I'm just going to put dot, 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 right? Do not round it until you enter that in the inverse sine, because then again, you'll be off if you round and then put it into your calculator. Now, if it's giving you an error, I mean, either you've done something wrong, or it shouldn't be the case that if you're given a side angle sine, it's not going to work. It should work out if they give you this, right? So you should not be getting an error. And I get about 59.3 degrees. But for this one, you do not have to. So we started, well, I guess maybe this is what we were talking about here, where start with the known angle and find the smaller of the 2 remaining angles. So we took that smaller side, or the angle across from the smaller side, and that's what we solved for first. And we don't have to do, so I'm going to note here, we don't need to check for another triangle like 180 minus 59.3, because it's going to be the first one we are given. And so what we can do is we can just find our last angle. If this is 59.3 degrees, we find C by doing 180 minus 38, right, minus what we just found, 59.3. And it should be 82.7. And so the reason in this case we don't need to check that is because that's always going to be the obtuse angle. And it in this case, it will most likely, it will either not work out. It'll be like one of those situations where up here, where there's not 2 triangles possible, there's only 1 triangle possible, or it's a right triangle. And so that's what we're looking at here. So that's why we only need, but they're saying that if we would have started with the bigger side, C and capital C here, then there might have been an issue when we calculate our inverse sine. I actually don't know if I've ever come across that, but if you do in your homework and like you did it in the wrong order and you figure that out, I mean, feel free to let me know. But they are saying that, I would follow this note that they give us up here, right? And this is specifically for side angle side. Okay. Now, the last type of triangle that we can get, or at least the last type we're going to see, is side, side, side. So that's this guy here, all 3 sides. So this is where you're given a triangle. You can't use Pythagorean theorem because you don't know if it's a right triangle or not. And they tell you that all the sides, we have 8.7 in this case, 10, and 12.3. So then I have, okay. And what this says here, we start with the angle opposite the longest side. if this is going to give us any chance to solve, we start with the angle opposite the longest side. And this is the only angle that could be obtuse. So for example, if you got a different angle, so the largest side is, well, typically they'll give you the largest side is C, right? And so we start with that angle. But if you ever started solving and then you got an obtuse angle, so you got 91 or you got 110 for B or A, the smaller sides, this is not going to be possible. They have to be across from the biggest side, because otherwise that means that if you get an obtuse angle here for B, that means C is also obtuse because it's across from the biggest side. And then you can't form a triangle. They must not be touching, right? The sides must not work out. So this is not going to work. So that is why they recommend, or they're telling you here to start with the angle opposite the longest side. It's the only side that could be obtuse. They might all be acute, right? But if it's going to have anything obtuse, this is what we want to start with. So, and that's almost always, that's almost always angle C. Like, unless they're writing the triangle differently, typically C will be the longest side. And so in this case that they give us, it is. And so we're going to say, okay, we're using law of cosines again, because we can't use, there's no angles here. We can't use law of sines. So we're going to use law of cosines, and we're going to have C squared equals A squared plus B squared minus 2AB cosine big C, right? So let's write that. Let's fill these in. 12.3 squared equals 8.7 squared plus 10 squared minus 2 times 8.7 plus 10 times cosine of C. Now, what we want to do here is we want to take this and subtract it from over here, right? And then we want to get this by itself, but eventually get cosine of C. So we want to eliminate this as well. So let's take a look. So we'll get, and because we want to round at the end, I'm going to just write everything out. 12.3 squared minus 8.7 squared minus 10 squared. You could write 100, I guess. Equals negative 2 times, 8.7 times 10 is 87. So I could just keep that, but I would still kind of write everything out here. And now I'm going to divide both sides by negative 2 times 87. Right, so that I can cancel them here. And I get cosine of C is this whole big thing. Okay, and maybe I'll write it again. So 12.3 squared minus 8.7 squared. I'll divide by negative 2 times 87 equals cosine of C. And when I compute this, so now I can, I guess you do want to take the inverse cosine right here. But if you did round this, I think it is, if you wanted to check this number, it is between -1 and 1. So we shouldn't get an error, right? Okay. So let me do this. Okay, I'm just gonna write this. So inverse cosine of C, or I'm gonna do this. So if I cross out, I'm being a bit lazy, but also if I just do inverse cosine of this whole thing, right? This is gonna equal C. And I should get approximately, I think if you do like just this inside piece, or maybe I'll write it here, it's like about 0.14 and things, but don't round this till the end. And then I think I get C is 81.9 I'm rounding to 1 decimal, but keep in mind if your homework wants more, just keep that in mind. So now I have capital C, and I can find last angle, right? So to find my last angle here, I can do, oh wait, I only have one angle. Oh my gosh, I'm losing my mind. Okay, so we only found, let me label in the triple. This is gonna help me a lot. Let me label. So we have all of our sides, right? Side. We just found C, 81.9 degrees. And it's acute. So, I mean, this is gonna be an acute triangle. We still don't know B or A. So pick one or the other. I'm gonna do the smallest. Actually, maybe this is where we use that advice from before. I'm gonna do the smallest side. I don't know if this was on purpose or not, but now we're gonna do law of sines to get A, like capital A, and then we can subtract from 180 and get the last angle, right? So let's see. So I'm gonna get I'm gonna do 12.3. So I'm using, let me highlight what I'm using here. I'm using C because I know everything from C, and I'm gonna try to find A. So I'm using law of sines for this. So 12.3 over sine 81.9 has to equal 8.7 over sine of capital A. Which means, and of capital A, if I cross multiply, is 8.7 sine of 81.9 is divided by 12.3, right? And then, okay, take inverse sine of this. I mean, you can check again. You could just do inverse sine, and if it doesn't work, then you know there's an issue. Oh, why not? Why is the denominator -2? It's because, so when going back a ways, sorry, I just saw this question. I don't know how long ago it was, but when we look at this step here, right? Or maybe even, like just this here, I get a negative because the equation is -2ab cosine C, right? So I subtract over, so what I did was I subtracted a squared, I subtracted b squared, that's here. Then I get a -2 times ab, cosine C. So I have to divide by -2ab. Does that make sense?
Yeah, sorry,
Yeah, you just didn't see it. That's
further.
no big deal. This is good. This is why you asked.
I just looking for the formula that is in the book. It says like cosine angle C equal a squared plus b squared minus c squared over 2ab. So is this a formula?
It just switched. It just switched the negative
Yeah.
there. Yeah, that's fine.
Yeah,
So it switched.
alternate.
Yeah. And so what Jakob is saying, he's saying that in the book, they say cosine of C equals a squared minus b squared. Oh no, plus b squared
Plus.
minus c squared over 2ab. Right? But
Yeah.
notice what we did was we did cosine C is c squared minus a squared minus b squared over -2ab. It's the same thing. Yeah. If you just multiply everything in this one by -1 on the top and the bottom, that's what they did. So it'll get you the same thing. Okay. Well, and I'm going to erase one of these because I'm going to need this space for the answer. So, okay. So as I'm solving for A over here, I get that A is approximately, I do that inverse sine, and this whole thing was like 0.700 something, right? But again, I wouldn't round that until the end. and I got about 44.4 degrees. So now what you can do, so A, we've got A, we got C, right? And maybe I'll just circle what we're getting, A, C, and we only need B now, so to get capital B, we're gonna do 180 minus 81.9 minus 44.4. And so B should be about 53.5. And so this problem, they gave us every side, and our answer provided every angle, A, B, and C.
At 53.7 for some reason.
Oh, that could be, okay, that could be true. I might have rounded too soon because when I did this with the calculator, so that could be true. So we
Try
can,
that 180 minus 81.9 minus 44.4.
oh, no, even just this. No, you're right. You're right. That was just me writing the wrong answer then. Yeah,
Okay.
all good, all good.
Yes.
Okay, cool. So thank you for the correction. You know, it's one of those days. What is it, Tuesday or Thursday? I want to say if it's Thursday. I don't know when it's better or worse to be making mistakes, but okay. So now we're kind of summarizing all of the cases that we've looked at. So hopefully, I know maybe that was confusing, but there are a lot of cases when we don't have a right triangle, right? So the cases that were given are, so there's 4 cases we've seen. I'd say when you start with law of sines, it's either angle side angle or side angle angle, right? Or it's side side angle, but this was kind of a least favorite. We'll talk. So that's the first 2 is these 2, and this is no big deal. You're given angle side angle or side angle angle, and you just do law of sines till till you solve everything and you're good to go. And so this, like A and B are these and B and C is this, right? So something like this, you can solve. So from here, you find the remaining angle just by subtracting from 180. So using 180 equals A plus B plus C, right? So we just subtract those 2 angles from 180, and then you use your law of sines to find the other 2 sides, right? So that's a good one. Now, the not so fun one is side side angle. This is the ambiguous one where it's like, who even knows? So these 2 are connected, they give you, and then they give you a little C. And so that would mean that, like, this is big C and the others are A, right? So what I mean by ambiguous here is you have some options. You either have 2 triangles, 1 triangle that works out, or no triangles, right? So this is kind of well, to me, it's the worst one, but maybe it's the most fun one because you have to figure that out. I don't know. And then this last piece here is if we are given side 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 or side angle side, we will have to start with law of cosines, right? And the reason being is because there is no known ratio to use law of sines. So looking like across at each of these, like nothing is given, right? Oh my, what do I do? Okay. I don't want to like draw on these triangles, but nothing is given across the way. So we just have to start with law of cosines, and then we could keep using it if our heart desired, or we switch to law of sines to help us, and then we just subtract from 180 and, to find those other angles.
When you say ratio, you mean like knowing little a and big A.
Yes, so exactly. So thank you for clarifying. When I say ratio, I mean like here. Like here we have a ratio, here we have a ratio, and here we can get the ratio because we have these two angles and we just subtract from 180 to get that other angle, right? Does that make sense?
Yes.
Okay, cool. Awesome. Okay. So these are all of the possible cases that we would have here. Now, if we want to look, so these last ones for to hopefully I can get, and I think there's some like will be probably less, so let's,
Audio is breaking up. Yeah, video too, apparently.
oh no. Okay. I've probably lost you on the iPad. That's what's happening. All right, am I back?
Yeah, your audio is back, yes.
Okay, all right, yeah, my audio's back, but who knows what the heck's going on with everything else. Okay, that's fine. Okay, so keep with me here, hopefully. Yeah, please holler if like I lose you on the iPad. Or actually, well, I guess you can't holler, but hopefully this works out. Okay, so a helicopter is on a path directly overhead line AB, and it's observed from locations A and B separated by 200 feet. Okay, so they draw this picture for us, so that's good. And we can label like little a will be across from big A, little b will be across from big B, right? And we'll let this be little c, and so this is angle C. And then it says if the angle of elevation from A is 39 degrees. Okay, so from A, it's 39 degrees. Okay. And then angle of elevation from B is 20 degrees. Okay, 20 degrees. What is the distance from each location to the helicopter around to the nearest foot? So we want to find little a and little b, these sides. What are these distances, right? Okay. So if we want to find these, well, luckily they gave us two angles. So we can just do 180 minus 39 minus 20 to get big angle C, which should be 121, I believe. So this is 121. It definitely helps to label your triangles too if you have a picture like as you go, because I've gotten confused if I don't do that. Now I can use that famous law of sines, right? And I can look at this first and say, well, I have 200 and 121. I definitely want to use that. And then I can just, doesn't matter, but I can start with A or B. I'm going to just start with A, going alphabetically here is what I did, but you can do either. So it should be 200 over sine of 121 degrees has to equal little a over sine of 39 degrees. And then 200 over 1 sine of 121 degrees has to equal little b over sine of 20 degrees, right? And both of these will get us, we can just multiply by the denominator, right? Multiply by this and multiply by that and rewrite it. So we get little a is 200 sine of 39 over sine of 121. And little b is 200 sine of 20 degrees over sine of 121 degrees, right? And so, and remember, we'll round to to the nearest foot, because that's what they're asking, and it's in feet. So when I round this, I'm getting 147 feet for little a and 80 feet for little b. So that just means that whoever's at A and whoever's at B, right? This is the distance they are from the helicopter. Or was it a helicopter? Yeah, it is. Okay, cool. Haven't totally lost my mind here. Okay, So the next one, I'm gonna draw this heinous picture and then, you know, we can all breathe. Oh, I'm gonna plug in my laptop, so I'm probably gonna lose everybody, but let's just see. Maybe that's why I lost it. My computer's at like 20%, but, okay. So to estimate the height of the building, all right, I'm already picturing my bad drawing, but 2 measurements are taken. The first shows an angle of elevation to the top of the building. The second is 100 feet closer to the base, is an angle of elevation of 78 degrees. Okay, so lots happening here. I'm gonna draw a picture for you and just bear with me, okay? So say, here's my building. Here's, you know, okay, here's the windows. I don't know, it's a high rise, or we're supposing, right? Oh, I don't know why you have windows on the first floor. You probably shouldn't, but okay, or maybe you do. Maybe it's one big window. Okay. And there's no door because why would there be a door, right? So this is the side of the building. So here's our building. Lovely. And we know that with the ground, right, it's going to form a right, we're looking at a right triangle, but we're going to see that that's not what we're looking at really. So they're saying 2 measurements are taken. The first one is an angle of elevation to the top of the building is 43 degrees. So, okay, I'm going to say, okay, we're going to draw something and we'll call this A and we'll say this is 43 degrees. But then it says 100 feet, the second measurement is taken 100 feet closer to the base. This is the base of the building and it's 100 feet closer. So I don't know, maybe that's here, right? And the angle was, what was it, 78? So, okay, now I'm gonna draw this. Ooh, okay, let's pretend that's nice and they all come together. And this angle is 78 degrees. Totally not drawn to scale, but we're okay with it, right? We're just surviving. Okay, so what's happening here, and X is the height of the building. There's the height of our building, let's say.
100 feet between A and
And yeah, and exactly. And I'm gonna label this as 100 feet, right? We don't know really anything else. So suppose that's little c. And suppose this angle, I'll call it big C. And then suppose this would be little a, and then maybe this is B and little b. Okay. So now you're seeing my triangle kind of coming together, but what I haven't done is I know the 78, but that's not what I'm interested in. I want to know what's this angle, because then I have angle. I can get this angle of my triangle. Oops, well, hold on, I kind of drew that off. I can get this angle and be looking at my my triangle, like my triangle ABC, and solve. What I want to do is solve for this A, because then I can use trig with 78, A, and X to solve for X, right? So that's what look at this mastermind, you know, okay, I'm not the mastermind, but look at this, us being a mastermind. This is what we will do, right? So first things first, I mean, to get, this is actually B, right? Maybe I shouldn't have written it in blue because like, I don't know if that's confusing. So this is our B. And to get this, I just do 180. B is 180 minus 78. So it's 102 degrees. Okay. And then what I want to do, well, if that's 102, I can do, to get, this is C up here. So to get C, I can do 180 minus 43 minus 102, right? And that should be 35 degrees. So this guy's 35 degrees. Okay, sure. And now, lucky me, I've got a match. I've got 135 across from each other. And then I can match 43 with A, right? And do my law of sines and try to get little a. So let's do that. So I'll write 100 over sine of 35 is going to equal little a over sine of 43 degrees, and do my thing, cross multiply, and divide by sine 35. Okay, if people aren't liking that, I haven't heard complaints, but this time I'll just do a sine 35. I'll do the whole cross multiply is 100 sine 43 degrees. Then I just divide both sides, sine 35 degrees, right? Divide the whole thing. And then I get little a is 100 sine of 43 divided by sine of 35. And we will round this, right? I don't know. Did they say? They said the nearest foot, but first, well, this isn't the final answer. So actually, maybe you wouldn't even round this, but I am going to tell you it's like 118.9, right? But maybe you wouldn't even round this. So this is a combo problem of law of sines and right triangle trig. So maybe it's pleasing everyone, or maybe it's pleasing no one. Who knows? So we've used, this was law of sines. Now, with this, or maybe I'll write it. Yeah. Next, we use right angle trig, because we look at our SOHCAHTOA, like I said. So now we're focusing on the actual building, because I only figured out they took these two measurements for us, but we didn't know the distance, the original distance here, so we couldn't do anything with that. Otherwise, we could have just used right triangle trig right away, if they just took some measurements, right? But now to do this, I have my A is 118.9, this angle 78, and this is opposite, and this is hypotenuse of my right triangle, right? So I'm going to do sine because it's so, right? So sine of 78 degrees should equal x over 118.9, right? So then x should equal 118.9 sine of 78 degrees. And they did say round to the nearest foot. So actually, maybe I'll just say it's like 116, I think. Right?
Yes.
So, so estimate the height. So building is about 16 feet. Final answer, right? And that's how we're going to solve this guy here. And this is like combining all of your fun knowledge from Tuesday and before and beyond, right? And before that and today.
I have a quick question.
Yeah, Colby, go for it.
So, right here we used, what am I trying to say? We used the right triangle trigonometry. But so we can't use law of sines and cosines to solve for 90-degree angle triangles.
Okay.
You know what I'm trying to say?
Yeah, I do. So yes, I want to say yes. Let me think a little bit about this. Okay. Just so I can, this will come back to me, but so if we were to use that, right, it would be like x over sine of 78 would equal a over, 118.9 over sine of 90. Now, sine of 90 is 1, right? Wait, is 90? Hold on. Give me a second. Yeah. Sine of 90 is 1, right? So 90 is pi over 2. It's, for whatever reason, it's easier in radians. But so this is just 1. So really, okay, yes, you can use law of sines to answer your question, Colby. However, it would be a bit silly because this just turns into 1 and you're literally just doing, what we just did. You're basically doing right triangle trig, if that makes sense.
Okay, I see.
Do you see what I'm saying? So you're
Yes,
basically then getting okay, if I multiply both sides by sign, and then I would like, I basically get, actually, I get exactly this. X equals A 118.9 times sine of 78. So you can absolutely use it. Like law of sines is good always for any triangle, but the right triangle trig SOHCAHTOA trick is only good for the right triangles.
Okay, thank you.
Yeah, yeah. Good question though. Had to think about it. So you stumped me for a second, right? Okay, so, oh, the updates. So for people that came in, I really want to mention this. I will post these notes tonight, but for people that came in just even a few minutes late, because I tried to start right on time. Where's my, okay, tonight, actually now, if you refresh Blackboard, there will be a quiz there. It has 5 questions. It's not crazy, like don't stress. It is due Sunday. I don't know what time, I can't remember, but it is due Sunday at some time. There is homework in Alex on 7-1, 4, 2, and 3, but I made this due Tuesday before class. So it is by 6 p.m. You cannot, I mean, okay, yes, you can turn in later, but it will be late. I will not extend that, right? So reminder, quiz in Blackboard due Sunday, homework in Alex due Tuesday before class, right? I can't, I want to promise you that I will grade the quiz by Tuesday, but I just don't know how my week is going to go. And if you turn it in before Sunday, I might grade it like as you turn it in, right? But if I don't have all of them graded by Tuesday, I probably won't go over the quiz answers until like Thursday or another time. So if you're really wanting to go through it, or it's graded and you're like, oh, I have so many questions, try to come to office hours on Tuesday or send me an email in case I don't go over it in class. Just because I have zero clue like how much time I'm going to have and when I'm even going to do that. Right. Oh, let me try to see if this saves. Oh, let's hope that's saved. So I will post this. Yeah, it looks like it did. Okay, great. So I will post that tonight. Our question of the day, and I want to say I even already asked this, but this week it's going to be, or today it's another easy question, I guess. Cancel. The question of the day is going to be, what is your favorite like Halloween candy to eat, to get when you trick-or-treated as a kid, what to hand out, like whatever you're doing. I don't know if college kids trick-or-treat, but I'm sure some people do. But I will be handing out candy. So if we were in person and if I have leftovers, I would be bringing the candy to class so that I don't eat it all. This is what I did last year, but I typically don't have leftovers, or I eat them all by the time, anything happens. So yeah, so go ahead and throw in your favorite candy there for Halloween, whether you're giving it out, eating it. And yeah, and this is it for today.